Hi and welcome to Qt World Summit 2021. This talk is about the new property system and making C++ more QMLish. My name is Fabian Kosmale and I'm a manager for the QML team. I'm also the maintainer of mock the meta object compiler. However, this talk will be neither about QML for the most part nor about the meta object compiler. Instead, we will explore the new property system introduced in Qt 6 and that's mostly C++. On today's agenda, we find 4 main points. We will shortly look at how property looked in Qt 5 and what's new in Qt 6. Then we will introduce QProperty and related classes which make up the new property system in Qt 6. We will show a short motivational example and then shortly explore the inner workings of the property system. So let's start with how properties looked in Qt 5. First in C++. Now, property in C++ was always placed into a QObject or QGadget, and it has a type and a name. In our case, the name is prop and the type is int. What can you do with it? Well, you can read it by using a getter. You can write to it via a setter. And if you place it inside a QObject, then you can add a signal which signals when the property changes. And for the most part, you were expected to emit the signal yourself unless you were using the member specifier inside the QProperty macro. Now, there is also QML in Qt, and in QML you also have properties, and it's a bit simpler. You simply write the property keyword, the type, and the name. The type is again int, and the name is myProp in this case. And once you do this, you already get the ability to read and write the property. And it should be noted that you cannot do anything custom in the getter or setter of the property, in contrast to C++, where you could do arbitrary things there if you were so inclined. Moreover, whenever you write property something in QML, we will automatically synthesize a signal for it, and that signal is called myProp changed in this case, or generally name of the property changed. And with that signal, you can react to it by using an signal handler in QML. Okay, and that's mostly what you could also do with C++, but there is one important difference, and that is that in QML we have bindings. In QML, we cannot only assign a value to the property like we did below when we assigned 24 to it, but we can also assign an expression, and this expression has various dependencies, namely other, x, and other.y. And whenever any of those changes, the update of myProp will be automatically changed. And set is quite a new feature because properties will be automatically updated without you doing anything once one of the dependency changes. And importantly for this talk, there was no equivalent in C++ so far for it. And as you might have guessed, in Qt 6, that equivalent has been introduced. So in addition to our read, write, and notify specifier in QProperty, we now have a bindable specifier, and this allows you to make your properties bindable in C++. The question you might of course have is now, how does it do that? And for that, we will explore a few classes, namely QProperty and its friends. So let's start introducing the property classes, starting with QProperty, the most basic one. What is QProperty? Well, it is a class template taking exactly one type parameter. In our case, we are using int, but it doesn't have to be int. It can be any type as long as it's copy constructible and copy assignable. We can initialize QProperty with any value of the underlying type, or we can leave out the initialization, in which case it will be initialized via zero initialization. And we can read and write the property as if it were the underlying type for the most part, because it is implicitly convertible and has an assignment operator which does the correct thing. But more interesting is that we can call a function called setBinding. And setBinding takes a functor or lambda which is expected to return a value of the underlying type again. And if we just do it, then it might look like we have assigned the return value of that lambda. So in our case, we assign to area the product of width and height and get 5000 in our case. But the most interesting part is that if we change any of the dependency of that lambda, in our case width or height, and they are also a QProperty, then the resulting value will be updated. And that's the nice part about bindings. They are tracking their dependencies automatically, so we just have our lambda here and didn't have to specify anything in addition that we are observing width or height. And if the binding is set and we change any of the underlying values, the value of the property gets updated automatically. We can do one more thing with properties, and that is we can install an observer, in this case a QProperty notifier, via the function add notifier. And anytime we now change the property, either directly by assigning a value to it, or indirectly, as in this case, by changing one of the underlying properties, it will execute the functions that we have installed on the notifier. And this will happen as long as the QProperty notifier is in scope. Once it goes out of scope, it will be removed. So afterwards, if we again change the property, nothing will actually happen anymore. And this is slightly similar to signals, but as you haven't seen here, there are no signals. In fact, there is no QObject or QGadget anywhere here. And this is intentional because QProperty doesn't actually depend on any part of Qt meta object system. But what if you actually would like to use QProperty with QObjects? Well, in that case, we can simply put the QProperty inside of our QObject derived class. In this case, we put two properties, width and height, inside a rectangle class. And we can expose setters and getters like normal. And the one addition we are doing compared to prior properties is that we will expose a bindable function via the bindable keyword in the QProperty macro. And this is to allow integration with the meta object system. And one thing that is suspiciously absent from the slide are signals. What we could do to add them to this class is to manually check inside our setters whether the new value equals the old value, and if that's not the case, emit the signal. However, the property based on QProperty already does similar work behind the scenes. Why? Well, it needs it to update any dependent bindings and to notify any observers of the property. So it would be a bit wasteful to do this again manually. So for that use case, we do have another class, and that is QObjectBindableProperty. What has changed compared to the last slide? Well, not much. We now have one signal for one of the properties. We could also add it to the other one, but for space reasons on the slide, we only using one. And so we have that signal also exposed to the meta object system. However, we didn't change anything in the setter. So how does the property know that it has to emit the signal? Well, that works by passing it to the property down here, and we are passing it to a macro called QObjectBindableProperty. You might wonder why it is a macro and not a class, and the reason is that behind the scenes we need one helper function, and that one is created by this macro. And when it comes to API, QObjectBindableProperty behaves like QProperty. That's why we didn't need to do any further changes in the setters and getters. It is only usable inside QObject because nowhere else do you have support for signals. And there is one additional benefit of it, and that is that it can save space if the property doesn't actually have a binding and is not used in bindings and is not observed. We come to that point later when we are talking about the internals of the property system. Now, at this point, there is one important thing to note, and that is we have to give you a warning about custom setters. Let's consider this class broken. It has a single property, small, and in its setter, we check that the new value we are trying to set is not greater than 100, otherwise we will return. Now, you might expect that when we are creating a binding with that binding, and it returns a value larger than 100, 500 in this case, it will also not update the property because the setter rejects it. However, bindings do not use the setter. Instead, they write directly to the underlying value. So don't use custom setters with bindable properties. Now, this is a limitation, and we are working on overcoming it, and we do have private API to do it, but because we haven't nailed the API yet, we do not want that to expose it to you so far. And so for now, like in QML, properties which are bindable should not use custom getters and setters. Now with that warning out of the way, let's focus on the last class which we want to explore today, QBindable. QBindable is used to expose our properties to the meta object system via bindable, and It can be constructed from a pointer to either QProperty or to a QObjectBindableProperty or a few other classes. So it acts as an abstraction over the various property classes and allows us to change the internals of our object without breaking the API. You can use it to manipulate the underlying property, like setting bindings, removing bindings, setting the value, and even reading the value. And you could actually do this by exposing the property by itself if you don't need the abstraction. However, there is one further benefit. It allows us to expose the bindable to the meta object system. So just like you can read and write a property via the meta object system using QMetaProperty, you can also receive the bindable. This is normally not important in day-to-day usage, but it might be helpful in some scripting contexts, and it is what helps QML to interact with the new binding system. As the last part of our exploration of the new property classes, let's discuss the differences between change signals and notifiers. As you have seen with QObjectBindableProperty, you can combine new style properties with signals. And on the other hand, we have the new concept of notifiers, functions that get executed whenever the property changes. So these seem to fulfill a similar use case. And the question is, when should I use one and when the other? Well, with signals, you get various benefits. The connection that is created has some automatic lifetime management, which means that it will stay alive until either you explicitly disconnect it or until any of the involved objects gets destroyed. With notifiers, you get back some handle, and the lifetime of that notification logic is tied to the lifetime of that handle. So you have to manage the lifetime more explicitly. On the other hand, the notifier works with any property class and can thus be used outside of a QObject, whereas signals are inherently tied to QObject. A further advantage of signals is that they can be used across multiple threads and that you can use queuing. Notifiers do not support that, and like bindings, they must not cross threads. Now I've talked quite a bit about the various property classes, but we haven't really seen them in action so far. I'd like to change this with a small example project. We are modeling some subscription service and we are trying to calculate the price of the subscription and expose it via some API. And how is the price calculated? Well, it depends on some discount, the duration of the subscription, and on some kind of base price. And the discount depends on the duration again, and the base price depends on the country of the user. If you're in Norway, it costs more, otherwise it costs a bit less. Now, the user has a bindable property country, and the subscription has two bindable properties, duration and price, and the latter is read-only. And what we are simply doing is, well, we accept a user in our constructor of subscription and use it to compute the price. And by using that binding, we ensure that the price is updated whenever the duration or the country of the user changes. And as you can see, there is nothing visual about this. So many people might be exposed to bindings in the context of UIs, notably with QML. However, there is nothing inherent about using bindings for UIs. You can also use them for business logic. And if you do that, you can then, however, later decide to integrate it with your UI and even with a widget's UI. So what I've done for this small project is I've created a few buttons to set the various properties, namely duration and country, and the buttons will just update whatever happens. And then we output the price via a change handler and put it on a label. And in action, it looks like that. We can change the interval and can see that the price does update. And we can also change the country, and if I click on Norway, it gets more expensive, and in Finland and Germany, it's less expensive. Now you might wonder, did we really need bindable properties to achieve that result? Well, the answer is actually no. Even in Qt 5, we could have basically gotten the same result by creating a slot update price and connecting the various property change signals to it. However, I do believe that the current approach with bindable properties makes for a nicer implementation. Why? Not only do we need not any boilerplate to create the connections, because the binding tracks any dependencies automatically. This also ensures in the future that any change that we might do is automatically reflected. For instance, if in base price we would no longer depend on the user's country, but maybe on his age, then we would automatically track that new value and no longer track the user's country. And in that way, we have better maintainability of our project because there is less boilerplate and more work done by Qt itself on behalf of you. After the short demo, we have now arrived at the final part of this presentation, which will be about the inner workings of QProperty. We will focus on two parts today. The first one being the memory layout of QProperty, which will help you to judge the space overhead it incurs. And the second part will be about binding evaluation. Now let's dive into the memory layout of QProperty. Conceptually, it consists of three parts. First of all, you have the current value of the property. Then you have a pointer to a list of observers and a pointer to the binding. The list of observers is a linked list with next and pref pointers, and each list node stores a function callback, which gets executed whenever the property changes. The binding contains also of a function which computes the new value of the property. Now I mentioned that this is only a conceptual memory layout and it's not the actual layout. Why is that the case? Well, because with this memory scheme we end up with an overhead of at least 2 pointers. However, that's a bit much and we can do better. So what do we do in practice? Well, we only use one pointer and it can point to either a binding or to a list of observers. But what if we have both a binding and list of observers? Well, to handle that case, the binding now stores that observer list. Or if we don't have a binding, then we can simply store directly a pointer to the observer list. And we have neither, then of course our pointer will be null. And to track whether we have no binding or have a binding, we simply use 1 bit of the pointer which would otherwise be unused. With this technique, we can reduce the memory overhead to set of one void pointer plus maybe some alignment and padding. Can we do even better? Well, not with QProperty. However, with QObjectBindableProperty, we can improve the situation even further. With QObjectBindableProperty, we do not actually store any pointer directly. Instead, we only store the value. Now, we might still need a pointer to store e.g. a binding or the list of observers. However, this time we allocate them on demand. How does it work? Well, in the private of the QObject, we store a map from the property to its observer or binding pointer. And only when those are needed do we add an entry to the hash map. This means that the overhead of QObjectBindableProperty, when used as a property in Qt5, so no binding related stuff at all, is basically 0. And that concludes our exploration of QProperty's memory layout. On to the very last part of this presentation, binding evaluation. Here we will check in more detail what happens when you have multiple bindings and one of the dependencies changes. So here we have 5 properties and then we change A to 42. What happens next? Well, this will start a 2-phase process. In the first phase, we will do the actual binding evaluation. So A has been changed to 42 and will notify its dependent bindings. That will cause B to update, and B will in turn notify D and E, and D will update and E will update, and afterwards B is done and A continues to notify C, and finally C notifies against D, and D reaches its final value of 84. Now this is slightly suboptimal because D has been updated twice. Once when B was updated and now again when C was updated. And if you had evaluated the properties in a bit smarter way, then we would have gotten away with updating D only once. However, that would have required a global view of the dependency graph and doing a topological sort on it. And in the general case, we deemed that to be too expensive, so that doesn't happen. However, there is one optimization that we can do, and that is related to notification. Basically, at this point in time, we only have refreshed bindings. What we did not do was to notify any observers or to emit change signals. This happens in a dedicated second phase. In this phase, we again traverse the binding tree and first we'll notify the observers of A, then those of B, those of D, those of E, and finally those of C. And at this point, we are actually done. We do not do a second notification of D. Why? Because we have marked it as a property that has already sent out its chain signal. And why can we do this here and not with bindings? Well, notifying observers is a pretty binary thing. Either you did it or you didn't. However, with bindings, you have to refresh the binding function again, because else you would stay on an outdated value of the property. Basically, if we would have skipped the second update of D, it would have stayed at 42 instead of 84. That concludes this talk about QProperty and its friends. I hope it has piqued your interest in using properties and bindings, and in case you have questions, we welcome you to ask them in our Speakers Lounge. See you there and on the next Qt World Summit. Bye!